Welcome to Design of Concrete Structure course. So today is lecture number 20. So till now we have discussed about the theory part. In the last lecture we have discussed about theory part of the design of foundation. So we have just covered all the basic elements of such a design, starting from beam design, and then we have discussed about column design, and lastly slab as well as staircase also we have designed. So in the last lecture number 19, we have derived the different types of, we have seen different types of foundations, and which case which type of foundation is used, and what are the design considerations for design of foundation, and also all these parameters we have discussed in details. So in this lecture number 20 will be solving a numerical problem, and basically how to design a plain concrete footing, that we'll be discussing in this lecture. So here let's get started. So what is the question here? Question is design. So design a plain concrete footing. So every term in the numerical is very much important. So plain concrete footing means there won't be any longitudinal reinforcement. Okay, means although we have to provide nominal reinforcement, but primarily the design should not be for the longitudinal reinforcement. So design of a plain concrete footing for a column of 400 mm into 400 mm carrying axial load of 400 kilonewton under the service loads. So assume the safe bearing capacity of the soil is 300 kilonewton per meter square at a depth of 1 meter below the ground level. So use M20 and Fe415 grade of concrete steel for the design. So these parameters are given. So let me write the parameters which are given to us. So first one is given to us is the dimension of column. So this is a column and the dimension is given to us. This is a vertical cross section and foundation will be something like that. Okay, so it is a plain concrete footing and the reinforcements are also coming from the column, and we have the minimum longitudinal reinforcement provided at the footing. So this will be beneath the ground surface, and how much total load is coming, that is given to us. Total load, how much load is coming, that is 400 kilonewton axial load is coming. And what is the cross section of this column which is given to us, that is 400 by 400, right? So this is given to us, and we have to use M20 grade of concrete and Fe415 grade of steel. So what is meant by design of plain concrete footing? So here design means we have to find it out what is the dimension of the footing. Dimension means what is the height of the footing. So what is this height, h, that we have to find it out. Okay, then what is the length and width of this column? So like here you have the column, right? What is this length? What is this length, that you have to find out. What is the breadth or width of the column? So W as well as L of the footing. So all these parameters you have to find out, and also the reinforcement. So what type of reinforcement, what is the diameter, what is the spacing, all these parameters you have to find it out. So that we actually meant by design. So in this problem we'll do a complete design of this beam, of this footing. So let's get started. So our first step is to check whether the transfer of axial forces at the base of the column. So how much forces it will be transferred to the base of the column, and whether the longitudinal reinforcement is required or not. Because in the question it is said that to design a plain concrete footing. Plain concrete footing means that we should not design for the we should not provide the longitudinal reinforcement at the bottom of the footing. But first we have to verify whether do we need really longitudinal reinforcement or not. So it is essential that the total factor load must be transferred at the base of the column without any reinforcement. Okay. So for that, bearing resistance should be greater than the total factor load Pu. So here two things are there. So one is, for example, let me draw it here. So you have the column here, and at the bottom you have the foundation, right? And the soil. So this entire part is below the soil. So the soil will have some bearing pressure. So this we call it bearing pressure of soil. So if bearing pressure of the soil is means if the quality of the soil or the bearing pressure of the soil is good, then the longitudinal reinforcement may not be, or maybe the that any reinforcement for transfer of load is not required. So first let's find it out. What is the stresses coming into the foundation? So load, axial load coming into the column is given to us in the question, which is 400 kilonewton. So this multiplied by 1.5 is the factored load factor or factor of safety. Basically, we are multiplying to get the factored load PU. So which is comes to 400 by 1 into 1.5, which is 600 kilonewton. So now our factored load is 600 kilonewton. So now if you visit clause number 34.4 IS456, there it is mentioned the design of footing criteria. Clause number 34 is the design of footing, and in that clause number 34.4 IS456, if you see, so this is the sigma BR is given to us. This is the bearing stress. Sigma B is the bearing stress. It means at this bottom level of the reinforcement, bearing stress, this expression is given to us. So sigma BR is equal to 0.45. So 0.45 FCK is for the limit state of design, and for working stress, if you are using the working stress method principle, then this will be 0.25 FCK. So in the clause number 34.4, you will see all the criteria here. So 0.45 FCK A1 by A2. So what is A1? A1 is what is the total area here at the beneath foundation, the foundation of the this one. So A1 is this what is the area of the column itself. Like here, A1 is what is the cross-sectional area here. So this is A1 and this is A2. Okay, so A1 we have to compute, and so we have A1 and A2. So sigma BR is we are to find it out. So let's assume that our column dimension is given to us, which is 400 by 400, right? 400 by 400 is the dimension of this column. So A1 is given to us. So let's assume A1 equal to A2, because we don't know what is the length of the footing and all. Till now we have not identified what is the length of the footing and all. So what we did is A1 equal to A2. Let's consider at the beginning. So which is comes out to be 400. What is A1? A1 is the cross-sectional area of this column part, right? It is given to us in the question 400 into 400. So 400 into 400, which is section 1,60,000 mm square, is the total cross-sectional area. So we are assuming A1 equal to A2 at the beginning. So if you substitute A1 and A2 value here, then you will have the bearing force, which will be nothing but this multiplied by A1, because A1 will be cancelled out. Okay, so you will have ultimately this is the final force. Okay, so as 1.44 sorry 1400 kilonewton is the maximum force that this one can take. Okay, so that is given to us. So now we computed using this formula that our soil can take maximum of 1440 kilonewton axial force, or the force. But how much is applied? Our force applied is total 600 kilonewton, right? So the soil or this foundation can take maximum of 1440 kilonewton, whereas the applied load is 600 kilonewton, right? So it is very less, right? Thus the full load PU is possible without any reinforcement at the bottom. We can transfer the whatever entire load is there, that we can transfer it. So our first check is now over. Now we'll go with our step 2. So step 2 is the size of the footing. Now to computation of size of footing. So now you can see this is actually the footing. So it is a plain concrete footing, something like that, right? So our main objective is to find out what is the height, what is the width, right? Width and length of the footing, and this is a column, right? This is a plan view and this is a cross-sectional view. In the plan view, you can see this is the entire footing, and middle portion is you have the column, and this is the height, total height. Okay. So now let's assume the weight of the footing. So what is the weight of the footing? Weight of the footing will be this area. This entire portion is concrete, right? This is concrete weight plus the soil load. So here also some soil is there, right? So soil filling will be there. So this weight of the soil also will be coming to the footing. So that also we have to consider. So the total, so the assume the total weight of the floor and the backfill of the soil. So how much soil weight will be there? That we approximately assume, which is 15% of the PU. The total load is coming 600. So let's assume 15% of the PU, whatever load is there, that is the backfill weight. So then the base area required. So how much base area will be required for that is, so the total load, how much is coming? Total load is coming 400 is anyway, is the weight coming from here, 400 multiplied by, we consider this backfill. Backfill means the soil part. So weight of the soil also is coming, right, in the foundation. So here also you have the soil. So which is we considered 1.15%, right? 15% of the PU. So 1 point multiplied by 1.15. So this is the total load coming into the foundation here. Now what is the bearing pressure of the soil? So that is given to us, that is 300 kilonewton per meter square. So the bearing pressure of the soil grade here is given to us, which is 300 kilonewton per meter square. So maximum 300 kilonewton per meter square stresses the soil can take, right? That is given to us. Then how much area is required total? How much force is coming? Force is, we know this is the force, and how much stress it can take, that also is given to us. So from there easily we can find it out, right? So stress is what? Stress is equal to force by cross sectional area, we know. So stress is given to us like 300 it can take, right? 300 bearing pressure it can take. The soil bearing capacity is 300. Force we have to find, force also we know, force is this one, 400 into 150. So force is 400 into 1.15. Easily we can compute what is the area A. So A will be nothing but 400 into 1.15 divided by 300, right? So from there easily you can compute what is the value of A. So A value will be comes out to be 1.533 meter square. So that much cross-sectional area is required. So that much cross-sectional area of the footing is required. So you have the column at the center 400 by 400, and this is the total area, which is basically 1.15 mm square is minimum required. So let's provide, so we are providing a square column, right? Square column means we are providing 1250 by 1250. If you just root square of this value, you will get something like 1250 by 1250 area we are providing. So now this figure you can see this is plan view. So we have provided length is 1250, width also 1250. So now we know the dimension of the footing now. So how much we provided? We provided 1.5625. Okay, but minimum required is 1.5. So we just provided little extra, so that's okay. It's shown in figure here. Now what is the total bearing pressure coming? Bearing pressure is total force divided by cross sectional area. So force divided by cross sectional area is 294.4 kilonewton per meter square. And how much bearing pressure the soil can take? It is 300. It's given to us. So soil can take up to 300, but what is the stresses coming into the soil? That is 294. So it is less than this. So our structure, our footing is safe. So now in step 2 basically we computed what is the size of the footing. So size of the footing means 1250 we just computed. So now we have to compute what is the height of the footing, means this height, that also we don't know, we have to compute it. So our step 3 is the thickness of the footing. So thickness of the footing computation, you will get it this formulas again in the IS 34.1 in that clause 34.4 clause number, you will find it out. This is the formula for finding out the thickness of the footing. So what is that? 10 alpha equal to, so what is 10 alpha? What is alpha? So if I draw a footing here, so this is the footing and this angle is basically alpha. Okay, that we are computing now, 10 alpha. So this formula is given to us in the S456, the clause number 34. You will get this formula 10 alpha equal to 0.900 QA FCK plus 1 root square. So just plug in all the values. QA is the total stress is going into the soil, which is just in the previous slide we computed 294, right? If we convert into the appropriate unit, then it is 0.294 divided by FCK is M20 grade of concrete we are using plus 1. So if you substitute all these things, you will get 10 alpha value is 1.414. So alpha is basically this angle, right? So from this angle, so this angle is alpha. So now easily we can compute what is the height. So what is total length here? Total length already we computed 1250, right? So we are now finding out this height. What is this height? So alpha value we know. What is alpha value? Alpha value 10 alpha is this much, and this h we have to compute height, and this length is how much? So this length will be total length 1250 minus, so not this, actually it is up to middle portion, okay, up to middle portion. So minus 400, 400 is the thickness of this column, so this is the thickness of the column 400, so minus 400 divided by 2, so that is the simply this length. So this length divided by if you do this length divided by the 10 alpha, basically you will get what is the height, right? Simply tan theta we know already, right? Tan theta is equal to height by base. So using the same formula, we know base, we know tan theta, we can easily compute the height. So same formula we have used and we computed what is the height required. So height means this height is required is 601.37 mm square. So let's provide. 670 because 601 is minimum, so let's provide extra with clear cover and all. 670 mm, you can provide 650 or 700, anything is fine. So we provided now 150 1250 into 1250 is the plan area, and height is 670 block, plain concrete block, for the foundation purpose, footing purpose. So that is our step 3. Now step 4, although as per our codes said, we have to provide the minimum reinforcement also, and whatever maybe the required reinforcement, we have to provide even the minimum reinforcement here. So minimum reinforcement as per our IS 456 is 0.12%, similar thing like slab. So we have to consider this footing as a slab, and in slab also the minimum reinforcement you have to provide is 0.12%. So same area we are providing here as well. So AST value is 0.12 into cross sectional area. This 1250 is the one dimension, into height is 670, so that much minimum reinforcement we have to provide it. So provide 9 bar of 12 diameter. If you find it out how many bar required and what type of bar you want to provide, so you will get it what is the number of bars, and any diameter you can choose as shown in the figure, and the spacing also you can compute it easily. So provide so total bar with the spacing, so easily we can now compute it using the using this formula. So AST now computed. Step 4. Now last step 5 is the check for the gross pressure. So whether we have to check now our base or the soil can take the entire load or not, entire stress or not. So how much is the service load? So assume the unit weight of the concrete is normally we know 25 kilonewton. 25 kilonewton is with reinforcement, but here we are considering the plain reinforcement, plain RCC without reinforcement. That's why the the unit weight is 24 kilonewton per meter square is considered, and the unit weight of the soil is 20 kilonewton per meter cube, and service load is given to us 400. So what is the weight of the footing? So weight of the footing, so total height is 0.67 into both the dimensions, right? 1250 is the dimension, multiplied by 24 is the unit weight of the concrete, which will get that much is the weight coming from the footing. Now similarly, weight of the soil also will be there, right, at the top. So if you see the second slide, so this is our foundation, so this is our footing, so weight of the soil will be coming here. So this height is 330 we considered, right? Total is 1 meter, right? 1 meter depth, the values are given to us. So 330 is the soil, 330 is the weight of the soil. So 330, so multiplied by this area cross section, the plane area of the footing, which is we computed 1250 by 1250 into 20 is the unit weight of the soil. From here you get the weight of the soil. Weight of this portion soil is 10.31 kilonewton. So what is now total load, total service load acting on on this level of the foundation? If you add 400 plus 21st 10, so which is 435 kilonewton. So from there you compute what is QA is coming out to be force divided by cross sectional area, will get it 27 kilonewton, 278.68 kilonewton per meter square, which is less than 300. So 300 is basically the bearing pressure of the soil, which is given to us in the question, and how much load is applied into the soil, which is 278, which is less than 300. So hence our design is okay. So that's how we can design a plain concrete footings using the IS code. So we have now almost completed our the syllabus, like starting from beam design, column design, and then slab design, and the staircase design we have done. Also today we have completed the uh, foundation design also using the only plain concrete footing. Thank you.